Hey guys, welcome back to my channel. Today we are going to learn about knapsack problem in data structures and algorithm. So quickly now let's get started.
So suppose you are a mischievous child camping in the woods. You would like to steal items from other campers, but you can only carry so much mass in your knapsack. You see 7 items worth stealing. Each item has a certain mass and monetary value. So how do you maximize your profit so you can buy more video games later? So the value and mass of each item is given. You have to maximize your profit. Subject to mass constraint of knapsack is 15 kg. So being a smart kid, you use dynamic programming. Here's the solution of how to solve it. Now comes the sensitivity analysis. Valuables are not very valuable when camping. Pick richer people to steal from. Suddenly a valuable item of $15 that weighs 11 kg is available. Will the optimal solution change? Yes, the maximum profit becomes $23. Here's another knapsack problem. Given some items, we have to maximize the total value. Each item has some weight and some value. The total weight cannot be more than a fixed number W. So we must consider weight of each items as well as their values. Here's how to solve the problem. Now there are two versions of the knapsack problem. The first one is 0-1 knapsack problem. Items are indivisible, whether take an item or not. Some special instances can be solved with dynamic programming. Second one is fractional knapsack problem. Items are divisible. You can take them any fraction of an item. Now, 0-1 knapsack problem. Given a knapsack with maximum capacity W and a set S consisting of n items, each item I has some weight Wi and benefit WPI, and we are considering all the integer values. The problem is how to pack the knapsack to achieve maximum total value of packed items. The problem, in other words, is to find maximum summation Bi subject to summation Wi less than equals to W. The problem is called 0-1 problem because each item must be entirely accepted or rejected. Now comes the brute force approach. Since there are n items, there are 2 to the power n possible combinations of items. We go through all possible and find the one with maximum value, with total weight less or equal to W. Running time will be O2 to the power n. Dynamic programming approach. We do better with an algorithm based on dynamic programming. We need to carefully identify the subproblems. Here's another knapsack 01 problem. Now comes the recursive formula. The best subset of Si that has the total weight less than equals to W either contains them or not. The first case is Wi is greater than W. Item I can be part of the solution since if it was, the total weight would be greater than W, which is unacceptable. The second case is Wi less than equals to W. Then the item I can be in the solution and we choose the case with greater value. Now comes the 0-1 knapsack algorithm. Running time. So what is the running time of this algorithm? O and W. Here's another example for the algorithm. Now conclusion. Dynamic programming is a useful technique of solving certain kind of problems. When the solution can be recursively described in terms of partial solution, we can store these partial solutions and reuse them as necessary. Running time of dynamic programming algorithm versus naive algorithm. Thank you.